46 is 1 plus I into 1 plus 2I and so on into 1 plus Ni equal to x plus Iy. Then 2 into 5 into 10 into 1 so on into 1 plus n square equal to. So this is given in CET 1998. So this is just taking the modulus on both sides. So you just need to take the modulus on both sides and squaring on both sides and use the definition of modulus of complex number to get x square plus y square as the answer. So this is straightforward from the definition of ellipse. So the definition of ellipse is the locus of a point which is such that the sum of the distances from two fixed points is always constant. For an ellipse, you take any point on the ellipse, the sum of the two distances, suppose this is f1 and f2, and p is such that pf1 plus pf2 is always a constant k. Right. So this is the definition of ellipse. So using that, this represent the distance from the z point, that is basically the p point, to the minus 4i. Minus 4i is basically 0 comma minus 4, and this is 0 comma 4. The sum of the distances of z from these 2 points is equal to 10 always. Automatically this represents ellipse. It is straightforward from the definition. We will learn little more in detail in the corresponding chapter, the conic sections. This is again, this is z minus of minus 1 plus I. These represent distance from a point, and this is z minus of 1 minus I. So this is also distance from another point. So basically the set of all points which are equidistant from two fixed points. Minus 1 comma 1 is a fixed point and 1 comma minus 1 is a fixed point. Set of all points which are equidistant from these two fixed points is the perpendicular bisector of line joining those 2 points. You can see that any point on this line is equidistant from these 2 points. You take any point on this line so that it is equidistant from these 2 points that satisfy this condition. So the z satisfying this condition, the options given are a line, a circle, a parabola, a hyperbola. So automatically the answer is a line, because a line satisfying this condition. That's the answer. We know that omega power 3 is 1 and 1 plus omega square equal to 0. So using that, this is 1 minus omega square, and the 1 minus omega power 4 is again 1 minus omega, and this omega power 8 is omega square because 1 minus omega power 6. So the same thing 2 times you're getting. So just simplify the first part. 1 into 1 minus omega square minus omega plus omega cube whole square. And now we know that omega cube is 1. So it's 1 plus 1 minus omega square minus omega equal to 1. So this value is again equal to 1 whole square. 3 square is 9. So that's correct answer. So if you rationalize the denominator 1 plus I by 1 minus I into 1 plus I, the numerator is 1 plus I whole square, which is 2I. Denominator 1 plus I into 1 minus I, which is 2. The whole power m equal to 1. The I power m equal to 1. I power m equal to 1. The least positive value of satisfying that is m equal to 4. Out of the options also we have only 4, 5, 6, 7 are the options. 4 is the correct answer. When you have the higher powers, it's always convenient if you write that in the polar form to simplify. That's okay. Let us convert this into um, the rationalizing the denominator and all.
So what was the answer to the last question? The previous question, 50th?
Previous one is 4. 4. Number 4. See, when you have the higher powers, it's convenient to write the numbers in polar form. The 1 plus root 3i, if you try to convert that into polar form, 1 plus root 3i z equal to, then r equal to root of 1 square plus root 3 square, root 4, which is equal to 2. So then when you're converting into polar form, tan theta equal to y by x, which is root 3 by 1. And this lies in the first quadrant. Both are positive. So the theta equal to pi by 3. That's how we get this. And similarly, we get this. And if you substitute both of them, the 2 cis pi by 3 by 2 cis minus pi by 3, the whole power 6 plus 2 cis, this is not cos, cis, cos theta plus I sine, minus pi by 3 by 2 cis pi by 3, the whole power 6. The 2 get cancelled here and here. And we have another formula, cis theta 1 by cis theta 2 equal to cis of theta 1 minus theta 2. If you use that formula, this becomes cis of minus 2 pi by 3, the whole power 6, plus cis of minus pi by 3 minus pi by 3 minus 2 pi by 3, the whole power 6. So the cis 3 to 4 pi plus cis minus 4 pi. But actually for multiples of, even multiples of pi, minus plus doesn't make any difference because both can be replaced with 0. This is cis 0 and this is also cis 0. Cis 0 is cos 0 plus I sine 0, which is basically 1. So 1 plus 1 is 2. The answer is 2, option 1. It's given in 1995 CET. So to do this kind of problems, we have a Euler's formula. The cos theta plus I sine theta is represented by e power I theta. This is the Euler's form. Because if you see the options are given as omega square e power minus pi by 2 root 2. So they simplified somehow this I power I. The I power I equal to, I guess they wrote the base as cos pi by 2 plus I sine pi by 2. This is the polar form of I. So the base they wrote in the form of polar form. The power they kept as it is. And using this, the Euler's form, they wrote this as e power I pi by 2 and the whole power I. So the e power I square pi by 2, this becomes e power minus pi by 2. That's the third option. We know that I powers follow a cyclic order. I power 4n equal to 1 and I power 4n plus 1 equal to minus 1, which is equal to I, and I power 4n plus 2 equal to minus 1, I power 4n plus 3 equal to the minus I, this is just plus I. So they follow a cyclic order. So wherever you start, if you have 4 continuous powers as 4 continuous numbers, we may have this as 1 or minus 1. We don't know because n is a 2 multiple or not. Irrespective of whether it is 2 multiple or not, you get the same. For example, you take n equal to 1, then I square, I cube, I power 4, I power 5. So you'll get only these 4 numbers and their sum is 0. So the answer is 0. Yeah. And this is given in 1994. The right, numerator is 1 minus I whole square. Directly if you calculate, numerator will be minus 2i, denominator will be plus 2i. So cancel and then minus 1. Yes, straightforward. Option 4. We simplify, or you can cross multiply 2 minus I the whole square minus 2 plus I the whole square by a plus ib into a minus ib a square plus b square, 2 square plus 1 square and the whole square. Numerator is a plus b whole square minus a minus b whole square is 4ab. So because it's another way, minus 4ab minus 4 times of 2 into I by this is 5 square 25. So the modulus of numerator by modulus of denominator, modulus of numerator is 8. So 8 by 25 we have an option, that is second option.